Okay, continuing with data structure, we're going to do mode and class now. So in R, every object has a mode, which indicates how it's stored in memory. So it could be stored as a number, as a character string, as a list of pointers to other objects, as a function, and so on. So we can have numbers, vectors of numbers, character strings, vectors of character strings, what's called a factor, a list, a data frame, and a function. So an example of a number is of course something like this, and the mode would be called numeric. An example of vector is something like this. It has two elements, and the mode would be called numeric because it's a vector of numbers. A character string, something like mo with quotes, it's called the mode is character. Vector of character strings, so like this, 3 elements. The mode is character. Factor, like this. We're creating a factor, and the mode, is that right? That looks wrong actually. Let's check it afterwards. List, creating of a list, and the type, the mode is list. Data frame, and the mode is still list. Now a data frame is a list, but remember that it has certain restrictions. It can't just be any list. The elements have to have the same number of elements in them. So this has 3, and this also has 3. And the function, like the print function, and its mode is function. Let's check some of these. But first let's just say, so the types of the modes can be numeric, character, list, and function. So here we have a vector. Let's try that again. So it's the mode is numeric. Now let's try the one that I wasn't sure about. So we have this one. Okay, it's true. So it's kind of surprising. So the mode of a factor is numeric. Okay, a critical difference between a vector and a list can be summed up this way. As we've said, in a vector all elements must have the same mode. In a list, the elements can have different modes. So mode gives us the physical type. The mode function gives us the physical type for the element, for the object. So what I mean by that is it the physical type really is it numeric, character, list, or function? That's sort of how it's stored in the computer. And the class is the abstract type. So in R, every object also has a class which defines its abstract type. A single number could represent many different things: a distance, a point in time, a weight. All those objects have a mode of numeric because they are stored as a number, but they could have different classes to indicate their interpretation. So the class is sort of, in object-oriented programming, you have classes and subclasses, and this tells you the class. So, for example, a date object consists of a single number. So here we're defining, we're using as date. We're taking actually a string and using as date, so we're creating a date object. Try that again. And so if we check the mode of this, it's going to be numeric. But there's also a class function, and if we check the class of this, it's going to be, there are various types of many different classes, and this is going to be of class date. In R, every object also has a class, so which defines its abstract type. The terminology is borrowed from object-oriented programming. A single number could represent many different things. A distance, a point in time, a weight. All those objects have a mode of numeric because they are stored as a number, but they have different classes to indicate their interpretation. R uses an object's class to decide how to process the object. For example, the generic print function has specialized versions called methods for printing objects according to their class. So if it's a data frame class, it'll print it'll use a certain program or algorithm to print it. If it's date, it'll use a different set of code. If it's LM, it'll use a different one, and so on. When you print an object, R calls the appropriate print function according to the class's object. Okay.